Good morning, students. Okay, so today's seminar that we have arranged is basically on career opportunities in CAD/CAM CAE. I hope you all guys are from second year, third year, and final year mechanical engineering students. And you might be knowing that whenever you take admission for any mechanical engineering course, your students, friends, or who are seniors or who are your relatives, they always tell you that you have to go for CAD/CAM CAE. That is the field which is having a very good career opportunities for you in terms of getting a job and as well as getting a good salary. Now what happens is mainly, as you know, like when student takes admission for electronics or electronics and telecommunication, computer IT, they have a dream that they want to get into information technology and companies like Infosys, TCS, and Wipro. But when you go for a BE mechanical engineering course, always students will say that I need to get into CAD/CAM CAE. But many of the students who are in second year or first year of mechanical engineering, they really don't know what actually you have to do so that you can excel yourself and get placement in terms of CAD/CAM CAE. Now, ultimately, what is happening is that there are so many engineering institutes that are coming up, and because of the competition, there are so many students coming out, and you do not stand between the mass, like what exactly you have to do so that companies can absorb you. So in today's presentation, what I'm going to do is I'll be informing you right from scratch what is CAD/CAM CAE, how it helps you to develop your career, what exactly you have to do in this particular 3 years of time that you are having, and then what industry wants from your side so that you can get placed in the industry. So this will be the contents of my presentation. Before I start with my presentation, I'll just brief you about our company. As you know, we are representing IFS Academy. So IFS stands for Infinite Solutions, which is our parent company, and we mainly deal with engineering design services. So we work for many companies like L&T, Tata Motors, Thermax, SKF Bearings, for providing them engineering design solutions. Now design solutions in the sense they have got a project and they need to go for a solution. So how that solution is obtained is mainly because of the aid of the softwares as well as the knowledge of engineering design. So these two are the main things in which we work for. Then we go for technical staffing. Now technical staffing in the sense, say let's take an example of a Tata Motors company, or let's take an example of Cummins. Now these companies require people or manpower on a particular software, say on ProE or say on ANSYS. Now eventually what happens is they just don't require a BE mechanical engineer. They require BE mechanical engineer with knowledge of ANSYS, but how it can be incorporated for their domain. That is also a very important thing. Now what is that domain? Say Cummins is working on engines. Now how ANSYS can be used for engine domain, that type of training we are giving and then sending the employees to these companies so that they can work on their projects. And with this thing in mind, we started IFS Academy, which is basically Center of Excellence in CAD/CAM CAE. And now we are providing training on all the latest CAD/CAM CAE softwares that are available in the market, and for students, faculty, as well as for corporates. We are also educational partners of ANSYS, Mastercam, and PTC. And recently we have tied up with Parametric Technology, that is PTC, which is our authorized training center. So PTC has appointed us to have authorized training center for their Creo 2.0, which is formerly known as ProE Wildfire. So we are allowed to do a certification program under PTC University for students, and students will avail a PTC University certificate as well. Now let's start with today's presentation. First thing that we are going to see is the definitions. Now you might be knowing, whenever people used to say CAD, the first definition will be your computer aided drafting. The main thing that we do is computer aided drafting, or whenever people used to say CAD, it means AutoCAD. But the definition has totally changed now. We say that it is computer aided design. Now again, whenever we say computer aided design also, students will say designing means a 3D modeling concept, like conversion of a 2D drawing into 3D drawing. Now that is also not correct idea. What is basically design? When we say a design, say we want to design a new product. Let's take an example of a cell phone or a new car or a two-wheeler. Now, what are the concepts or aspects that you take into account? The first thing you take into account is your cost, then manufacturing, then aesthetics, then ergonomics. Now, when you consider all these aspects together, you get a proper design of the product. Now, while doing all these activities, how this will start? It starts with intuition of an idea. Like I have given you an example that you want to launch a new handset or you want to produce a new car. So that is intuition that came into my mind. So your PLM cycle, PLM stands for product life cycle management. So the cycle started when an intuition of idea came into my mind. Then you will make a rough sketch, then you will make a 3D model, then you will make a mold, or then you will go for manufacturing, design, then marketing, then produce, and then sold into the market. And then eventually it goes to the last stage wherein it is recycled. This is called as the product lifecycle management cycle. Now, when we are talking about this PLM, suppose an idea came into my mind today, and if I'm launching the new product, say after 5 years, it would be an obsolete product. So what needs to be done is that whenever the idea comes into our mind until the product gets launched, the time between that period should be minimized as far as possible. And how that can be achieved? That can be achieved with the help of computer aided design. Now we will be going into detail one by one what actually we are trying to get into computer aided design. Next is CAM, which is called as computer aided manufacturing. Now what happens? As a student, you might have worked on center lathe, wherein you might have done a job was put up on your notice board and a stock was given, and then you decided the process sequence. Now what was the process sequence? Like you will be doing facing operation first, then you will be going for turning, then you will be going for parting, grooving, drilling, one by one. And for each process, you have a speed and feed defined. And then on the process sheets, you wrote down the complete process sequence, step 1, step 2, step 3. Now what we do in CAM is basically this entire process sequence, we convert it into a NC part program, or which is also called as CNC part program. What is NC or CNC? It's numerical control or computational numerical control. So with that, the software automatically generates the G and M codes. So if you are making a 3D model of that particular component, then the software will generate the G and M code, which is basically NC or CNC part programming. And then that part program can be connected to CNC or VMC machines and machining can take place. It involves your lathe also, milling also, and drilling also. In some cases, wire EDM also. And with the software, just by sitting on the software and the computers, you will be able to see the toolpath simulation as well, like how your cutter is following a particular path. So that's also a beneficial thing for you. And third thing is CAE, which is basically called as computer aided engineering. Now here it is very important. Suppose like you guys are sitting on a chair and now you have designed this chair. Let's take an example. I have given you an exercise wherein you have to design a chair. So what you will do is you'll search for different options, then you will make some sketches, you will finalize the design, then you will finalize what would be the material, like it would be a metal chair or a wooden chair or a plastic chair, and then you will market it into the actual field wherein it is being manufactured as per the material. But you haven't tested the chair. Tested the chair in the sense, a normal weight of a person who is sitting on the chair is say average 60 to 70 kg. Now, when he is sitting on the chair and if the failure occurs, is it a good design? No. Similarly, if you imagine components like connecting rod or crankshaft, which are actually going to be used in practical field, and if you have not tested whether they are designed properly to withstand the practical loading conditions or not, will it be working? No. Or say, example, bridges that are built, if they are not tested out, like whether they'll be withstanding the loading conditions of vehicles which are passing at a time, then it will definitely lead to a failure. So for that, what needs to be done is design validation. So what CAE does is that we do design validation. In the sense, simple thing would be, if you're having a say cantilever beam also, if the load is applied, what is the deformation, what is the stress, you will be checking out with the help of softwares. Once the checking is done, then you can manufacture it and use it for your practical applications. Now, there are two things into this also. We are talking about structures. We are also talking about fluids. Both the things are important. We'll be going into that one by one. Now let's take CAD. If you can see the complete list, if you are able to read out the complete list, you will find that each and every student has got a career opportunities for each and every bullet that is being mentioned here. We will go one by one. The first thing that we have already seen is your 3D modeling and detailing. Now 3D modeling, in the sense, you can say classic example would be conversion of orthographic into isometric, or two-dimensional axis into a three-dimensional axis. That would be the one thing. Second thing is product design and development. As I said, when you go for a new product design, it could be, like I said, cell phone or a new car or a new bike or new laptop, anything, a new product. It goes through a lot of designs changes. It goes to a lot of processes. So these processes will be done faster with the aid of these softwares. Data conversion, third thing. Now data conversion is again 2D to 3D or 3D to 2D. Now let's take an example of, say, Tata Motors. Now Tata Motors, suppose, have decided to adopt Pro-E software for all their design processes. Now what happens when Tata Motors selects Pro-E? All their vendors who are supplying parts to Tata Motors again need to go for such kind of software. And as you know, they are vendors for so many years, and they are using the practices, and the drawings which they are having are basically blueprints. You might be knowing what is a blueprint. You have done it in your graphics or machine drawing exercises. Now what happens? They need to do a conversion of all these blueprints into a solid model or a product data management system. So therein you have got a huge potential of working on 2D to 3D conversion. That is very important. Next is reverse engineering, which I hope all the student knows what is a reverse engineering process. Everybody does this task. Whenever a term work is given to you, what you do mainly is that to look out for where the assignment is already being made so that I can copy it. That is the main thing what student does. So similarly, whenever you're trying to have a new product launch into the market, the first thing that you do is whether such kind of similar product is available in the market or not. If that is available, what companies are doing with reverse engineering now is that 3D scanners are available. Now what this 3D scanner does is that they take a 3D image of the actual component, and then that data which is retrieved from the software can be taken into a 3D modeling software, and you can make changes in that particular product. And ultimately the final design can be easily made, because you might be knowing, right, starting from scratch is a very difficult and timely process. But if you're getting a ready-made design which is already available, you can just scan it, make the changes, and then launch into the market. So that is a very good thing. Optimization. Now, a very good definition of optimization would be to find out better answers for the problems for which already you're having good answers. In the sense, let's take an example of your institute. Now there are so many colleges here, but take an example of any one particular institute. Infrastructure facilities are same, staff is same, your syllabus is also same, question paper is also same. but still the marks obtained by students are following into different categories. Some get distinction, some gets first class, some gets failed. Now why this is happening? It's because of whatever input resources you are having, you're not trying to optimize it. What is optimization basically? Optimization is to maximize your output with the limited input that is available. I'm not saying that you have to go for less input and maximum output. I am saying whatever inputs are available, with that can you optimize your design. Now, in case of engineering, what happens is mainly the weight optimization and shape optimization. Again, if I go to say Tata Motors, I'm a vendor of Tata Motors. I'm supplying different components to Tata Motors. If I reduce say few grams also for per component, then you might be knowing that how much amount of money I am going to save, because that is how it is going to help me out. So that's a optimization process for you. Then you have product and process engineering. Now, product and process engineering in the sense the same thing what you did for your CNC machining program. Like you are having a product and you are writing a process sequence with whatever your G and M codes, same thing. Rapid prototyping. Again, when you are talking about rapid prototyping, when you make a final design, you directly don't go for actual manufacturing. What you do is basically you go for a prototype. Now prototype is basically a reduced scale component, and normally now what we do is we make a clay component. Now clay models have been made which are having a very small dimension, but you can visualize it properly. That is called as RPT. And RPT is also possible with the help of CAD. Suppose you have designed a big assembly, you're not going to actually manufacture as per the dimensions, though it could be a clay model also. But with CAD, what you can do is just reduce your scale and make a small assembly which will be actually showing you the visualized effect of that particular assembly. Now, next very important thing is surfacing, styling, and BIW. BIW stands for body in white. Now, when you are moving on the roads, you see a lot of automotive cars like Mercedes-Benz, BMW, Audi. Now, when you look at them, the exteriors that they are having, the surfaces that they are having, or the sheet metal components that are being used, you really get amazed to see that. Now, how they are doing it? They are doing it through CAD softwares only. That is why it is called as body in white or surfacing or styling. Now, if you see the exterior surfaces, they are like very smooth and it has got a catchy thing in that. Now, developing these free surfaces, these are actually free surfaces. What is a free surface? It doesn't fit any mathematical relationship or equation. So ultimately what happens, these free surfaces are very difficult to design as well as to manufacture because they are of sheet metal. So developing molds and dies for them is a very difficult task. And you might be knowing CATIA is the most popular software for doing these activities of sheet metal or surfacing. And you have got a very good potential for it. I'm just giving you an example. So that's why this is also a very important aspect wherein you can think of developing yourself. Like those who are in third year or final year and wish to go for MS in automotive after doing GREs and GMAT. So they can think of learning CATIA and developing themselves in this particular field. Then comes rendering, animation, and visualization. Now, those who are in second year or already completed second year, you might have used ProE or CATIA softwares. When you are developing a 3D model, the color or the appearance that you have of a 3D model is normally a gray color figure. I'm talking about a by default color that is available. Now, if you print the same gray color figure on your brochures or leaflets or put it on your websites, will it attract the customers? No, if suppose a handset is given and the handset 3D model is prepared with the help of gray color and it is being put on website, now will it attract you for purchasing? No, it's not possible, because what you need is basically a photorealistic image. Unless and until a photorealistic image is not present, it will not attract customers. So for that, rendering is done. Now, what is rendering? applying the actual effects. So it could be a metal, non-metal, plastic, colors, the feel, all these things will be applied, and then the model will look like as if it is a photorealistic image, a 3D image. Even if you see the flex banners which are put on the roads of bikes and cars, you feel that it is like a 3D image. So that is how they are doing all this stuff. So you have got a very good potential for that. Then comes technical publication. Now, whenever you're trying to buy any product, it could be your handset or car or a two-wheeler or any product, you get an information booklet along with it. And it has got all the technical descriptions, certain views, certain photographs that are being put. That is also done with the CAD, because suppose you have to put exploded views, isometric views, drawings. You have to write the technical information in a neat and proper language with technical information, of course. So for such cases, you require softwares, and mechanical engineers are having a very good potential into it. Then obviously, if you can see the last slides also, you can go for jigs and fixtures, welding, casting, piping, structural CAD, architectural CAD, electrical CAD. So the point here is that when I'm talking about a CAD, it's not only a 3D modeling or just preparing 2D drawings. You have got so many things, and you can decide any one domain out of this, learn a CAD software and develop your domain into that, so that it will help you for your placements. That's most important thing. Next, CAM. Now we have already discussed a lot of things about it, but mainly you can see that we are talking about the CNC part programming and NC part programming. And in that you are having turning, milling. In milling also you are having 2.5 axis, 3 axis, 4 axis, 5 axis, drilling, wire EDM. And this figure that you see, can you see here this tool, and this is the workpiece, and this is being the path which is followed. So on the software you will see how the tool is basically following a particular path. That is how it will help you to see how the processes are. Next, CAE. Now in CAE we are having two terms. One is called as finite element analysis and one is computational fluid dynamics. Now those who are from final year can be knowing what is finite element analysis. I'll explain you with the assumption that there are second year and third year students also. A simple thing would be, say you're having a cantilever beam, one end is fixed, on the other end you are applying a load and trying to find out what would be the stress or what would be the deformation. Now you will say that a procedure or a formulas are given in your books, wherein you can just write down the equations, put the values, calculate and get the results. But similarly, if I ask you that you're sitting on bench or sitting on chair, and now I tell you to find out what would be the stress induced in the chair, what would be the deformation of the chair. Do you have a formula for that? No, there is no formula. Even if you are very good in design and mathematics, you can sit for 6 months and devise a new formula. But ultimately what happens when you change a little design of the chair or the bench, then the entire formula will not be used for finding out. So what we do under finite element analysis, if you see the three words also, finite means a fixed number, element means a smallest part of that particular geometry or assembly, and analysis means doing design calculations to come up with stresses, strains, deformations, reaction forces. So what we do is we divide the structure into number of small parts and then try to find out what is the stress induced in that smallest part, and then do a summation of all so that you get the total response of the system. So in that there are so many things, like you can do static analysis, dynamic analysis, you can do thermal analysis like heat transfer, wherein temperature deformation, temperature gradient, heat flow, all these aspects will be covered. You can do life estimation also, like how many cycles the machine will work, how many years it will have a life. Process simulations like manufacturing operations, like forming, wire drawing, forging, extrusion, rolling, all these processes can be simulated with this. Then there are two interesting things available here. One is called as crash analysis and one is called as drop test. Now, what is crash analysis? Is basically the accidents that takes place. I'll give you a very good example. Suppose you have invested around 15 lakh rupees and you got a new SUV, let's say Mahindra XUV. And then you are saying, sir, we have invested around 14 to 15 lakh rupees and I am very much safe now. I can drive at any speed. I can drive like anything on highways, but I am safe. And I want to check whether I am safe enough or not by taking an accident. Are you going to do that? That is not possible. Means you cannot drive at whatever speed and check whether your vehicle is designed properly or not. But with simulations like CAE, you can actually see the accidents taking place. Now, if you are knowing ARAI, do you know what is ARAI? Automotive Research Association of India. It's located in Kothurud only, Pout Road. There they are having actual physical testing facilities. But ultimately what happens, the physical testing is very much costly. So that's why you go for such simulations. Next is drop test. Now you are having very costly electronic gadgets like laptops, handsets, or even the LCD presentation that we are having. Now suppose by chance they fall down. It's not your mistake, but by chance they fall down. Now what will happen? Now these companies do take care while designing them, but are you physically going to check by dropping your laptop or by dropping the handset whether they are designed properly? No, that is not possible. So what we do is that through simulations we can do different iterations, make the product fall down and then check whether it is designed properly or not. So that is possible in terms of analysis. Similarly, the motion of mechanism is also possible. Next comes is CFD. Now, when we are talking about FEA, we were talking in terms of structures only. But analysis is not only related to structures, it could be related to fluids as well. Classic case would be, say you are having a chemical plant, or you are having a boiler, or you are having a pressure vessel in which the fluid is flowing at a high velocity and it is a pressurized fluid. Now, how do we check it? You cannot just directly pass on the fluid and check. But with CFD softwares, it is very much easy to find out whether your structure can withstand the loading or not. Or let's take another example of a, say, for example, you are having a microwave oven and certain heat energy is given to it. And inside the system, what is the temperature obtained? Whether it is a uniform temperature, what is the temperature gradient? That type of simulation is possible with the help of CFD. Another things would be heat transfer, HVAC solutions, which we use for our cars as well. Now comes very important aspect is what are the softwares available? And you will say, sir, now we have learned everything. What is CAD, what is CAM, what is CAE, but how do we now go ahead? So what are the softwares available for it? The softwares available list is given. You can start off with AutoCAD, ZWCAD, Pro-E Wildfire. Now the latest version, they call it as Creo 2.0. Now they don't call it as Pro-E. Then you are having CATIA, Unigraphics, Solid Edge, SolidWorks, Space Claim, Thing3. There are new softwares also. Now the question arises is that, sir, you will say there are so many softwares. Now, how many should we go on and learn them? Because you cannot spend 10,000 or 15,000 for each software and get 10 certificates. Or other way around would be like your college has got a particular software. Now let's say you are having Pro-E and you learn Pro-E, and then when you go for final year, a company comes for campus interview and they say that we are having CATIA. So what are you going to do? Are you going to tell them that no, sir, we have learned Pro-E, so go back, purchase CATIA and then come for the campus interview? Is it possible? No, that is not possible, because there are so many companies and so many companies are using different variety of software. So I'll be giving you a guideline how to choose a software or which software you should go for. But See the other softwares also, like when you're talking about CAM, now most of your institutes are having master CAM, but other softwares are also available. CAMWorks, Delcam, Unigraphics CAM, CATIA CAM, HCAM. So these are all available. CAE, you can see. Now, why we focus on ANSYS more is that if you see meshing, meshing in the sense what we saw is cutting down the model into different elements. You will find ANSYS, ISM, CFD is there. When I talk about CFD, we just now discussed about CFD. You will have ANSYS Fluent and ANSYS CFX. Two softwares are available. When I talk about FEA solver, you are having ANSYS. And when I'm talking about explicit dynamics is mainly used for crash analysis and drop analysis. You will find LSDyna and Autodyne. So a complete CAE package is available under the umbrella of ANSYS. That's why many industries, academics, and even we are forcing the students to go for ANSYS. That is the advantage that available with ANSYS. Now, the question and its answer, how to choose a particular software. First thing you have to note down is where the software is used in the industry. Like every software has got a domain. It's not like that all the softwares are used in all the domains. Like if you take an example of CATIA, CATIA is mainly used in automotive, aerospace, BIW, surfacing, seatings, styling. So it has got a key domain in which it is being used. If you take an example of ProE, you will find engines, jigs and fixtures, piping and cabling, sheet metal, plastic. So it has got a particular domain. SolidWorks, if you're talking about all the small scale and medium scale industries are using SolidWorks for a generic 3D modeling tool. If you're talking about Unigraphics, again, more popular in terms of tool, die and mold design and mainly used in automotives. Solid Edge mainly for sheet metal applications. So the first thing you have to do is identify where the software is used. So this is your first homework, I can say, when you are trying to have a new product or learn a particular software. Then what are the key customers? In the sense where this software is basically used. Who are the users, end users? Because when we are undergraduating, we have a dream that after pass out, when I pass out as a mechanical engineer, I wish to go into XYZ company. So how you will be deciding that? Try to find out what are the users. So if you can say ProE, John Deere, Ashok Leyland, Eaton, Greaves Cotton, Tata Motors, L&T, there are big giants who are being using this particular software. Then you talk about CATIA, morely all the companies towards Bangalore, Airbus, Boeing, Volvo, Tata Technologies, Bosch, TJC, Visteon. SolidWorks, you can find Sulzer, Suzlon, Bosch, Raj Industries. UG, GM and Mahindra, they are the more popular companies. And Solid Edge is mainly used by Emerson. Emerson has got so many licenses and they work on that particular domain. So the first two things are over. Now the third thing is, the question arises is that which software or which degree should give you a job? Because there are two things. You are doing a BE mechanical degree and you're parallelly learning a particular software, a certificate program in that particular software. Now when you go for an interview, these two things are essential. If you are just a BE mechanical engineer, it's not going to help you for your job. You don't have a BE mechanical degree, but you have learned the software, that is also not going to help you out. So what you need is a complete mix of your BE mechanical degree and the software knowledge. So you should be very thorough in your mechanical engineering subjects with good academic record, and then parallelly you should be aware of the softwares also. So if you know both the things, that will help you to get a job. Now again, still the question is which software to go for. The third exercise would be just log into naukri.com or monster.com, which are basically job portal sites. Put these keywords like Pro-E or Creo, CATIA, SolidWorks, and see how many jobs are available. And out of the results that you get, how many jobs are available for freshers? That is also an important thing, because you will be graduating and you will be a fresher. So that data will give you an idea which software you should learn. And the last important thing is, whenever you appear for an interview, like I said, if you have learned Pro-E and suppose the company is having CATIA or SolidWorks, your answer should be, sir, I am a BE mechanical engineer and I know Pro-E Wildfire in detail. So my concepts of 3D modeling, graphics, machine drawing are very much clear. Even if I have learned Pro-E and you are having CATIA, if you give me 10 days of time, I'll be able to switch off from one software to another. Because the technology is not changing. It's just a tool. Like you have to design a block in Pro-E and you have to design a block in CATIA. What will happen is that few options will change. Rest all process is going to remain same. It's not going to change. So what you should answer is that you should proud be saying that I am a BE mechanical engineer and I know one software thoroughly. That's the main thing. If you know these two things, that's it. You'll be able to shift to other softwares also. So your answer should be very much clear that, sir, I have learned my subjects very well, thoroughly. I know them in detail and I know the softwares also. So that is how you should answer. Similarly, what are the domains for CAE? Like it's not only about CAD, we have to see about CAE also. Let's see about ANSYS. You will find aerospace, automotive, construction, consumer goods, energy, oil and gas. All these are the domains which are being used in ANSYS. Similarly, hypermesh, excellent pre-processing. The meshing activities can be carried out very good. Nastran, you will find aerospace, ship, machinery. Abacus, mainly for nonlinear analysis, and SolidWorks simulation, mainly for industrial components at a very small level, wherein you are just interested to find out what would be the stress and strain. That's it. Similarly, what are the companies? You have got ANSYS. You can say CRTI, Cummins Research Technology of India, L&T, Emerson, SKF Bearings, Eaton, GE, Whirlpool. See, once you know the companies, you will get an idea wherein you are trying to get into. Like suppose you have got an excellent academic record and you have learned ANSYS, what are the companies wherein I can approach? Because unless and until they are not having the licenses, your knowledge about the software is not going to help them out. So both the things are very much essential. Now comes the important topic. What industries wants from being mechanical freshers? Because that is also an important thing. Now, the first thing that you are having is your BE mechanical or production or automotive degree. So what I'm saying is the basic degree. If you are going for CFD, I would say that you need to go for MTech in heat power or thermal also. Second thing is academic percentage. What I have clearly mentioned is that preferably 60% aggregate of all 8 semesters. See, again, we will come back to the initial point. There are so many engineering colleges, there are so many students, and when companies are trying to filter them out, how they are doing the filtration process. There is a pyramid, okay? When you are there in between the pyramid, you should lie in between, means you shouldn't be there at the bottom, you should not be there at the top also, because both the things will hamper. So keep a track of how much percentage you have of all the 8 semesters, like those who are in second year or third year. Do the calculations now and try to predict how much you need so that aggregate of all 8 semesters will become 60%. I'm not expecting that you should have 60% each semester. If you're having that, well and good, but at least a minimum requirement should be fulfilled. Because what happens in our academy also, we do have a 100% placement assisted program, and students inquires through website or gives us a call, sir, I'll be able to take the admission, but will you provide 100% placement guarantee? Now see, I haven't seen the student, I don't know his academic record, I don't know his communication skills. I don't know how much in-depth knowledge he is having in terms of the software. Now, how can I guarantee them that they will be getting a job? Because all these things are very much important for your placements. Unless and until all these skills are not developed, you're not going to get a job. So that's why it is important to have all these aspects very much clear. Similarly, excellent fundamental knowledge about the subjects. As I said, it's not only about, say, learning the subjects, learning the software, and that's it. You should be very much clear about the physical significance of all the activities. I interview so many candidates for design engineers post. The first thing I ask them is that draw first angle and third angle projection symbol, and they are not able to draw it properly. Or suppose I give them a drawing, a simple drawing, wherein the front view, top view, left hand side view, right hand side view is given. And if I ask them what is the projection system that is being used, they are not able to answer properly, because drawing reading is very important, and that will come with the subjects like graphics, machine drawing, metrology, manufacturing. Metrology is important because you need to know the tolerances and manufacturing processes as well. Similarly, if you are going for CAE, subjects like applied mechanics, strength of materials, physical metallurgy, theory of machines, they are very, very essential. Next is good writing and oral communication skills. See, now whenever you will be going for a job, you will not be limited yourself to Pune and allied regions. You will be working globally. So how do we write emails, or how do we talk, how do we speak is very important. So what you write and what you speak should be understood globally, and parallelly you also should be in a position to understand what others are trying to say, because you will be working globally in all nations. So their pronunciation should be understood clearly. Knowledge of MS Office. Now you will say, sir, why you're talking about MS Office? My brothers and sisters who are very at the age of 8 years, 10 years, they are doing MHCET and they know all these softwares. I'm not talking about that. I'm talking about Excel and PowerPoint. So all the statistical calculations that you do, you should be able to perform in Excel, and you should be ready enough to prepare an international standard PowerPoint presentation, because students have got a different idea of making a PowerPoint presentation, like putting catchy images, making it colorful, bullets, using different colors. That is not the case. It should be a clear-cut PowerPoint presentation, how it is being presented at an international standard level. Then good interpersonal skills and teamwork. See, you will be always working in a team. So you should be able to get along with the people. See, you're having a strength of your class is say around 60. Then you are having other years as well. Then you are having other branches in your colleges. How you get along with all these people, that is very important, because team management is important phenomena in your career. Because at the start you will be going there as a junior design engineer, but say after 3 years, 4 years, when you become a team lead or when you become a manager, you have to manage people. And if your people management skill is not proper, then it's not going to help you for growing your career. So that is also an important aspect. A typical job requirement which was there available on naukri.com. So how it is being given, you can see the same things what we discussed are given. So they are looking for a SolidWorks person. Graduation is given, and in addition to that, he should know GD&T also, like geometric dimensioning and tolerances. Experience in SolidWorks, 3D and 2D. You can see Microsoft Office, Excel, Word they have mentioned, not PowerPoint, but they require Excel. Good interpersonal skills and teamwork, same thing what we discussed. GD&T, geometric dimensioning and tolerances, and good verbal and written English communication skills, because that is very much important. Experience, industry, what is the role, like what would be your job title, functional area, graduation required, location and keyword. Now, keyword is important because it will be there in your resume. This keyword should be there in your resume. Unless and until you are preparing a resume which do not have this resume, the keyword is not there in your resume, it's not going to help you out. So make sure that the keywords are present into your resume. Now, once we do all that, how your career path would be. See, you will be joining there as junior CAD engineer, then you will become CAD engineer, then you will become team lead. As I said, you will be managing a team of engineers of 3 to 4. Then you will become project manager, wherein you will be responsible for the delivery of the project, and the delivery also needs to be in time with proper quality, because then you're responsible for it. And then you will become engineering head of that particular division. In the sense, I will not say that you will become engineering head of Tata Motors, but you will become engineering head of a particular division. So let's say engines, or let's say air conditioning systems, or let's say other divisions. So this path you're having is for say next 5 to 10 years when you graduate. That means you can decide your path. Once you come up to this particular stage, once you become an engineering head of a company, then you are self-sufficient to take a decision where my career should go. Like, should I continue like an engineering head, or should I start my own business, or should I take some other assignments so that I can excel my career? So I'm not guiding you for your complete career till your retirement. So I'm guiding you of next 5 years, what you have. Similarly for CAE, again, same thing. You will be starting with junior CAE engineer. You will become CAE engineer, team lead, project manager, and then you will become engineering head. So ultimately, what I'm trying to portray you for the students is that two important things. First is focus on your mechanical engineering subjects. Learn them thoroughly. Don't just run behind the marks and the university examination papers. Learn them thoroughly. That is very important. Second is, now you have seen CAD, CAM and CAE. Learn any one software out of them very thoroughly. That means you should know one software in detail. Use these softwares for your educational background. Let's say in second year we learn Pro-E or Creo. Use it for all the subsequent subjects. It could be design of machine elements, theory of machines, for doing term work. Do certain small projects, add them into your resume so that it will build your resume when you are there in final year, and maintain your academic percentage. This is the key for getting into placements, because still you know that the market scenario is very bad. There are hardly any placements. What I know the situation again is that there are no jobs available for freshers. There are jobs available for experienced professionals, but unless and until you get an experience, you're not going to get a job. How can you build an experience? So that's the scenario. So ultimately, this is the motto, or this is the message that I am passing out. Use this time that you are having in your curriculum to develop your career into CAD/CAM CAE. So learn these softwares, learn the subjects thoroughly, do certain small projects, build your resume, and that will lead to a successful career in CAD/CAM CAE. So that's it from my end. With that was like what I would try to say within the limited period of time or the span that was being available. If you are having any questions, we will be having a question and answer session right now, or otherwise you can note down my contact details. My mail ID and cell phone is given. You can feel free to contact us at any point of time. And our offices is also located in heart of the city. It's located at Nurse Stop. So you can visit our office and try to get as much as information as possible. Any questions or queries that you have? Don't be shy in asking any questions. There are no issues. If you are having any queries, you can feel free to contact me, or otherwise my contact details are given. Please note down the contact details so that you can contact me whenever you have any difficulties. Well, thanks a lot for the patience hearing, and wish you all the best for your upcoming exams and your future career. Just last 2 minutes of information. As I said, we are PTC's authorized training center. So we are offering various courses in Creo 2.0, which is formerly known as TOEI Wildfire. So we are offering courses on that. Then we are distributors of ANSYS. So we are offering various courses on finite element analysis using ANSYS and CFD using ANSYS, ISM, CFD and Fluent. And then there are career programs also, which are having 100% placement assistance. So those students who are having any queries or who think that they would like to go for such kind of training programs, please feel free to contact us at any point of time. And I request you to visit our office once to get all the information, or you can log into our website ifsacademy.org, wherein you will find all the syllabus, the courses that that are offered, the placements that we have done, the tie-ups that we have done. We are having discussions with your JSPM Nare campus, wherein we are going to have an MOU with them for conducting the training activities. So that's also possible.
Hello?
Yes, please. Yes.
Excuse me?
Yeah,
Hello?
please go ahead. Yes.
Yeah, I'm Atul Chavan from ICOR, Imperial College of Engineering and Research. So I just
Okay.
wanted to ask the question if the keyword you mentioned
Hmm.
in your PPT, is it just about the softwares you learn, or is it anything else? Or I mean, can you just mention that it can be a foreign language or something else for the company, or it just has to be a software?
See, basically there are two things. When you are trying to apply for any particular job, proper English communication, of BE mechanical degree, and in-depth knowledge of the software. These three things are very much essential. We are not talking about that you should know a German language or some other language which will help you out. And I'm not talking about C or C++ programming language also. I'm talking about in-depth knowledge about the software and mechanical engineering subjects. That is essential.
So that is how you define a keyword.
Keyword in the sense, keyword is for resume selection. Say, if
Okay.
you're applying for a job and they require people on ANSYS, so your ANSYS keyword should be there in your resume, and you should have learned that software.
So
You got
thanks
the
a lot.
answer?
Yeah,
Thanks a lot.
thank you.
Any other questions? Okay, thanks a lot. Wish you all the best for your upcoming exams and career. Thank you.